three numbering schemes in networking. I'm gonna teach you those right quick. I hope we can do this in 30 minutes. Three numbering schemes in networking. The first one is really easy. It's the base 10, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's the base 10. In networking, it's called dotted decimal notation. Dotted decimal notation. Dotted.
I'm just gonna do it.
Decimal. Yeah.
DECIMAL.
Thank you, brother. DECIMAL.
Yes, sir.
Okay. Notation. No. Notation. It's real easy. It's based on base 10. Base 10, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what it's based on. Okay, it's dotted decimal notation. There's another one that's called hex. Hex. H-E-X. Hex is based on base 16. And it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Think about having 8 fingers and 8 toes, right, on each arm, on each leg, right? 8 and 8 is 16. So it's based on base 16. And of course, the one that we use a lot in computers, because computers only understand 2 things, that's binary, and that's base 2. Base 2. So we gotta learn all 3 of these today.
Notation basic?
I beg your pardon?
Notation base 10?
Dotted decimal notation, base 10.
Thanks.
Base 10.
Just gonna do this. You say it.
Okay, here we go.
Just like, yeah, you.
Hexadecimal and binary, the other one you know already. Base 10. I couldn't put this on one line. Dotted decimal notation, base 10. Dotted decimal notation. Let's move this down. I had to move this down. You with me? First one we're gonna do is hexadecimal. Let's do that one first, okay?
Yes.
Let's do that one first. Hexadecimal system is based on binary, it's based on, it consists of base 10. Oh my goodness, dyslexia is killing me this morning. Okay. Hexadecimal is built on the numbering system that's called base 16. Hexadecimal numbering system is built on something called base 16. See, hexadecimal means base 16, okay? And how do you get that? You have to do it like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So you count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See it?
Mm-hmm.
So whenever you see anything that's in hex, here it is right there. It's gonna have numbers and letters.
Yes, sir.
The letters always have to be between A and F. You'll never see G, you'll never see Z and all that. It'll be A and F. So here is hexadecimal. What you have to do is, you have to understand that if you see a hexadecimal numbering system, you've got to compare it with base 10 or binary. In the IT world, these are the 2 numbering schemes. These 3 numbering schemes you need to understand. I'm not saying you have to do it all the time. You just need to be familiar with it. Okay, so here's hex. I'm gonna convert hex into notation, dotted decimal notation. I'm going to convert hex into binary. Here's a chart. You don't have to read it, remember the chart. You just have to understand the chart. Do y'all understand what I'm saying? You don't have to remember, you need to understand it when you see it. Are we okay?
Yeah.
All right, so now, let's do the first one at the top. Hexadecimal 0 in binary is what? 0, 0, 0, 0. In dotted decimal notation, it's 0. Okay. The 1 in hexadecimal in binary is 0, 0, 0, 1. In decimal, it's 1. Okay. Now here's when it gets tricky. The number 2 in hexadecimal in binary means 0, 0, 1, 0. In decimal means 2. So in other words, everything on this side and on this side is going to match up until it gets right here. Look, 9 is 9, 8 is 8, 7 is 7, 6 is 6, 5 is 5, 4. You see it? Now watch this. Hexadecimal A is 10. Look, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 20. Do I have to continue? Say no. Okay. You get that. If I give you $10, you know what $10 means, right?
Yes,
That's, it's $10 in your pocket, right? But you get it. It ain't the same over here. See, 10 in what we understand every day is A in the world of hexadecimal. 11 is B. 12 is C. 13 is D. 14 is E. 15 is
F.
F. What is 16? I bet you don't
G.
even know. What is 16? Here. 16, what is hex for 16? See if you can figure it out.
G.
No, sir!
Yeah.
No, sir!
There's
Do you see G up there? I'm not yelling at you because you're not, this is how we learn. Do you see G?
No.
What would you do? What would you do over here? You jump over to the next number. See, we do this all the time. We don't even think about it. Look, watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do we do now? 9. What comes next? In our world. In our world, man.
10.
What comes next?
10.
Oh, how did you do that? How did you do 10?
Because
You went.
you went
What is
over
0?
a number.
You do it right. 0.
You started
1, 2,
over.
3. What did I do to get 10? I start back over.
Yeah.
0. What do I do over here? I put a 1 right here. Then I put 1. And then what do I do now? 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8,
8, 1,
1. Getting close.
9,
9,
1,
1. Tell me, what do I do?
0,
Start over. What was this?
2.
2. Do you see?
So,
Same thing over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, B, C, D. Take it slow.
E,
F. Now think. Don't just think before you yell it out. Just think in your mind. Okay. Start over.
0,
0,
1,
1,
0,
1,
1,
1,
1, wait, 2, 1,
okay, 2, 1, right?
3, 1,
1,
4, 1,
1,
5, 1,
okay.
6,
We're
1,
gonna get there, right? 6,
7, 1, 8, 1, 9, 1, 1, 0,
9.
0, 2.
Oh,
No, sir.
eight,
Uh,
eight, zero,
Ah,
one,
you forget.
A1. Eight,
You forget. We had 9. What comes after 9?
A.
A1,
Oh, A1. E2.
B, no, not 2.
B1.
B1,
C1.
C1. See, now you
B1.
see.
C4.
Now you see you in the world with 8 fingers. See, I know it's crazy, but that is the world of hexadecimal. Let me finish this. That would be D1. You're getting close. E1. F1.
One.
Now we gotta start all over.
0.
0, but this is not 1, it is
2.
2. Huh?
Uh-huh.
Okay. And then you match them up. But you don't have to do this in the real world because you can go on the internet and calculate. All right? I'm just trying to show you how I got this versus this. We good?
Uh-huh.
Okay. Now this one's crazy. The way I remember this is I always start out with 0, 0, 0, 0. Then 0, 0, 0, 1. See, this can only be either a 0 or a 1. Okay? So now, I'm done. Here, I have to go back and do a 0. So this has to be a 1. What does this have to be now? 1. Remember, this can either be a 0 or a 1. So I'll be 0, 1, 0, 1, 0, 1, right?
Mm-hmm.
So now, if this is a 1, what is this? It's still a 1.
Mm-hmm.
Okay? So now, next one. 0, 0, 1, 0. 1, 0, 1, 0.
1. 0. That's
What do you
0.
think it is? You can cheat.
0, 0, 1, 1, 0.
0, 1, 1, 0. 0, 1, 1, 1.
1.
I'm filled up with all ones, so next thing I have to do is jump
1.
1, 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. 1, 1, 1, 1. Ah, that's how we did it. Don't worry about it. You ain't got to remember this shit. This chart don't be there for you all the time. I just need you to understand how we did this. Okay, so this is what you got to do. Ignore that. Okay, go. 1, 2, 3, 4. Come on.
Take your time.
1, 2, 3, 4. You got to do this. You got to convert this into binary. Let me get the chart for you. See if I can do this right. Let's see. If I can find the chart. Can I run this again? Open. Won't let me do it. But, oh, I know how to do this. Stand by. Stand by. I'm gonna snip this for you, okay? Let's do a snipping tool. How about that? And I will minimize this. So now you got the chart on one side, right?
Mm-hmm.
You got this on the other side. What you have to do is, come on, do it. Convert this one right here in ones and zeros. Come on, do it. Convert to ones and zeros. Use the chart. This is hexadecimal. You gotta go find a 3.
What?
3 is, binary is 0, 0, 1, 1. So, 0, 0, 1, 1. Then go find 2. What is 2? 0, 0, 1, 0. 0, 1, 0. Then find 3. Then find 8. Shouldn't take you no more than 5 minutes. Right?
Yes, sir.
I got.
You got them all?
Oh, you want the whole list?
You gotta do all. Yeah. Do all of them. See, I gave you 2 examples. The second one is beyond easy. 0 in hex is 1, 2, 3, 4. 0 in hex is 1, 2, 3, 4. 0 in hex is 1, 2, 3, 4. Zero in hex is 1, 2, 3, 4. Right?
Uh-huh.
Come on. 5 minutes, hurry up. It is 8:43.
E1 is 0.
Don't get to sign in.
1.
You finished yet? Who's finished?
So even though the letters are lowercase, it's still stands.
Yeah, don't worry about the lowercase. Lowercase, uppercase, it's all the same. Where's your pencil? Oh, my bad, I'm sorry, you doing Star Trek on me. Star Trek, they don't have paper. They got tricorders. Come on now, hurry up, 5 minutes.
You should be finished by that. Can you come check mine? You gonna get up on the board and you gonna do the question.
I mean, you're doing it. This is your.
You first one, let's go. Mount up. Boom. Go teach the class. Yeah, go.
So basically what I did first was I took a picture of this one and that one. And then what I did was
Yeah, that's fine.
whatever it is, so it should be 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0. Is right. And then the second one was
Everybody agree on that first one?
Uh-huh.
Okay. You going, teacher?
E1, which is basically the same process, but you just focus on one letter first. And
Mhm.
then
Can't read that.
Okay, bro.
it was 1, 1, 0, 1.
Oh, I have
Then 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1.
Yeah, I'm sure.
Should be correct. The second one was 0, 0, 0, 6, 3, which was pretty easy because the first two are zeros, so it's really just 4 zeros, another 4 zeros. And the 6 is 0, 1, 1, 0. The 3
Pretty
is
sure he's right.
0, 0, 1, 1. Which should be correct. And then the last one, which is all lowercase, but that doesn't matter, is F-E, F-B, which, two-letter repeat, which should be easy, which is 1, 1, 1, 1. G is 1, 1, 1, 0. And then F is the same thing, which is 4 ones. 1, 1, 1, 1. And B is 1, 0, 1, 1.
Everybody agree?
Yeah.
Pretty straightforward. Don't worry, I'll enable this on the job. Sure. Here, we're gonna put an asterisk right here. Here's this little mark right there. Okay, everybody cool? You don't have to remember this, y'all. Y'all ain't gonna remember nothing anyway. I don't even remember. It's just, I need you to understand this numbering scheme, which is the hexadecimal. Because there are two places where you're gonna see hexadecimal in the networking world. One is the network card. The network card that's in a computer. The network card is in any computer. All network cards on all computers are unique. There can't be another network card in the world that has the same number. It's sort of like, trying to think of something. Okay, it's like your address, like my
Right.
house is 222, I almost gave it away. 2225, right?
Mhm.
Street. There's no other street in the world that has the exact same number at the exact location, right? There could be another 2225 Seven Oaks, but it might be in another county. But right here, if I put a number right here on this spot, and I call it 5555, there is no other number in the world that's gonna be 5555 here, because I'm standing here at this location. So think about a network card. It has a burn-in address. When I say burn-in, it's stamped onto the card, and it's in hex. You wanna see it? Let's see it. And you have to know this stuff I'm teaching y'all. So I'm gonna go out here. I'm gonna type in, you can type CMD. You get a terminal, right? You use CMD, command prompt. CMD stands for command prompt. CMD. Command prompt. Another way you can do this is, and you have to feel comfortable. The next 2.5 years or when you started this program, you gotta feel comfortable in using the command line. This is the command line where you can command to do crap, right? You have to feel comfortable in this arena, because this is the arena where people in the IT world, cyber world, AI world, this is where they live. And if you're not comfortable in this world, you gotta find something else to do in your life. I'm sorry, it's just the way it is. We ain't there yet where we just talking to a tricorder all the time, like, okay, speed me up. You know, you still typing them. Even on Star Trek, they doing this. Sometimes they talk. You know, ops, teleport me to the planet Zambamba. I don't know, something like Kryptonium or something, right? But they usually have this though. They doing this. At some point, you still got to type. So you got to feel comfortable in this world. So in Windows, I can type CMD, get to a command prompt. This is a terminal. Another way to get to this is right-click to start. Here, start. Everybody see start? Right-click start. Go up to where it says terminal. And terminal. That's another way. I'll say terminal. Terminal. And the third one in Windows is called PowerShell. They all kind of look alike. I didn't spell it right. I can do this. I can go ahead and type search. PowerShell. Oop. I spelled power. Try it again. P-O-W. PowerShell, right? See it? PowerShell. Cool beans? So we got CMD, terminal, PowerShell.
PowerShell.
These two are the key ones you're going to use. This is the one you're going to use a lot in Windows 11. Terminal. So I'm going to go to terminal. One is older. This is the oldest. This is the oldest. Okay? You can actually use this for programming. Just like you could Python or anything like that. It's like a programming language. Programming terminal. This one's not so much programming. This one's trying to act like Linux. And that's what Microsoft is trying to lean to, PowerShell. So it's still gonna be there. For programming, you got to write code in PowerShell. Let me just be careful what I say. Terminal is I consider terminal is like Linux. Linux uses terminal. So that's the key. This is old. This is like really old. It goes back to when I started in computers, which is in the 1990s. Okay, so I'm gonna do terminal. I'm gonna do terminal here. And then there are two types. One's called terminal and then admin. You'll learn that later. So terminal. There we go. All right. Now, I want to get some information about my computer. To get information about my computer, especially when it's related to the network. Yep. I type in a command called ipconfig, 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 space, / all. That's a lower, it can be a lowercase letter, A. Are you with me?
Yeah.
Everybody with me? I'll look for another color blue. All right.
ipconfig/all. It's gonna give you some information that's very important about this computer.
What is ipconfig slash
I don't know,
a?
why don't you look it up? GPT, ipconfig, I'm not really sure what the IP stands for. Internet Protocol Configuration? Think? What does ipconfig mean? Let's see. First person that ever asked me that. What does ipconfig mean? Internet Protocol Configuration. Can you teach an old dog new tricks? I just learned something. ipconfig is short for Internet Protocol Configuration. Thank you. I just learned something. Okay, y'all good? All right, so let's go to this cat right here. This is my network card. It's called an Ethernet card. You learn about in Network Fundamentals 1401. Okay. I want to focus on something that says physical address. Does everybody see it? Physical address?
Physical address. That's telling me the name of the number that's on my network card in the computer. There's a computer right here. Here, look. There's a computer in here I use to turn on every time I come in this class, right? That's a network card that's in the computer. We talked about this. Remember when we did the motherboard?
Yeah.
Right? Motherboard?
Every computer has a network card. Even my phone. It's wireless. Let's pick one. Let's pick one. Here. That's a network card right here. Right there.
It's on the motherboard. And you put a cable in it. Yeah, right in there. So the burned in network card is on the motherboard. It has an address. The address is in hex. How do I know it's in hex? Look at the number. It's kind of crazy, isn't it? Look at it.
I mean, you probably can't see. I don't know how to blow this up, y'all.
Right here. Physical address says the network card, the Ethernet card. Here's the physical address right here. 74, stay with me. 7486, E. What the hell? Well, what's over here where you see E?
1110.
Okay, that automatically tells me they're using hex. All network cards use hexadecimal, which is 16. Base 16. That's all I need you to know. That's it. That's it. You didn't gotta calculate anything. I'm trying to get you to, when you're reading information for a test that you're gonna fail, you need to at least know what you're reading. They're gonna give you this on a test. They're gonna give you something like this, and you're gonna say, oh, Mr. D already told me the physical address is in base 16. Why do I know it's in base 16? I see an E. What's that? And what's that? Isn't that this? It ain't this. It ain't this. So it's hex. So the network card on all computers is in hex. That's all I want you to know. And you know what hex is? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Stop. We good?
That's it.
All right, that's done. 8:57. Boy, come back to this. All right. It's gonna get ignorant right now. We gotta talk about another address. The network card that's in a computer is hard-coded on the card. It's hard-coded. Don't change. You can take that computer and take it to my house and the card doesn't change. It's physical. That's why it said physical address. Here's the weird thing, y'all. In networking, you have two addresses, two main addresses. One's physical, which is the card. One is logical. It's called an IP address. The problem with an IP address, y'all, it changes. It changes based on what network you're in. See, right now, where are we located? Where are we located? Gwinnett Tech, right? We all agree you ain't at your house, man, watching TV. Are we there? No. We are in this building. This building belongs to Gwinnett Tech. The network engineers in 100 building has given each one of these computers its own IP address. But it can change. IP addresses change all the time. All the time. Now you can make them permanent if you want to, but when you have like 10,000 computers, you don't want to go to each one of these computers and put in an IP address. That's crazy. You're going to use somebody else to handle that for you automatically. But you need to know this. I'm just telling you the basics is that there are two types of addresses. One is a physical address, which is the network card, and one is a logical address, which is the IP address. Which is the IP. Have you even heard the word IP address?
Yeah.
Have you heard IP? Have you heard TCP/IP?
No.
You have? You may leave.
Okay.
You've heard everybody. I'm making that assumption you've heard TCP/IP. Oh, you've heard IP. The IP part is the address. It's called Internet Protocol. It's an address. It's called logical because it changes all the time. Why? Right. Check this out. On my phone, right now I'm connected to the GTC Wi-Fi. The Wi-Fi has given me an IP address for this network that's on this campus. There's no other computer that has that IP address. But see, watch this. When I turn my computer off, get in my car, and get gone, somebody else may come in. He may come onto campus, and he might be given that same address I had. It's not permanent, right? It changes all the time. And that's good. That's a good thing because networks are supposed to change because networks are different. There's Department of Defense, military addresses. There are addresses at my house, at the library, Atlanta, Smyrna, Gwinnett Tech, Coca-Cola. Those addresses have to change all the time because devices are always turning on and off and changing. But the only thing that won't change is the physical address that's in the card. Right? Okay, we good? So let me show you the IP address for my computer. And if your system is on, you find out what the IP address of yours is. Which one do you want to use? Pick one. Terminal. You want to do the hardware or eBay? Terminal?
Terminal will be sweet.
Okay. There's terminal, right? Then what command am I going to type?
ipconfig /all.
Yes, sir. Space all, right? Go back up here to this one. Now, this is where we are. Physical address hadn't changed. Where is my IP address for my computer?
IPv4
That
address.
is, brother. IPv4. There is my address. My address right now, today, at this time, is 10.10.182.101. 10.10.182.101. 10.10.182.101. I'll tell you about this stuff later. 10.10.182.101. That's it. What's yours? Anybody got your computer? What's yours?
192.168.204.1.
110? You're looking at another one, I bet. Let's see here. Let's scroll up.
It's right here, sir. This one right here.
Now that's VLAN. That don't kind of that's not fair.
Oh,
Don't worry.
wait,
You try
there
the
it
first
is,
one.
right here.
There you go. What you got?
10.10.181.49.
49. So his is 10.10.182.
181.
Really?
Yes.
181? Really?
Yes.
Wow. 49.
Yes.
Okay, we can do that because this is changed right here. You learn that later. Okay. So what is our family? Our family is 1010. So most everybody's computer is going to be 1010. Then some of a long number here. This is our family. We belong to this family right here. 1010 family. So apparently those guys on another building, they just said, hey, I'm gonna let our computers be in the family called 1010, which is actually not bad. That's a lot of addresses, to be honest with you. Okay, I'm gonna let you see this because we're gonna go back to the other one, which is the dotted decimal. Remember our dotted decimal? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Dotted decimal addresses. Dotted decimal addresses. That's the hexadecimal. Dotted decimal addresses look like this. This is what they look like. Dotted decimal address that you give a computer. X. I get enough blue. X. Just go with the flow. Here's dotted decimal. Dotted decimal. X dot X dot X dot X. Now the X is important. It's going to be a number, and the number is going to be either a 0, all the way up to 255. That's the maximum it can be. In other words, this first spot, this X right here, is going to be either 0 all the way to 255. It could be a 9, it could be a 0, it could be a 12, it could be a 254, 255. That's it. Can't be a 256, can't be a 900, can't be 1,000. Does that make sense? I'm telling you what it can be. It cannot be this. You cannot have this. You cannot have 299. No. Can't be 299. It could only be 0 all the way up to 255. Same thing with this one right here. 0 all the way up to 255. Same thing here. 0 all the way to 255. Same thing here. 0 all the way to 255. So I could theoretically have this. Here's an address that I can give to that computer right there. 1.1.1.1. I can do that. I can do this right here. 10.10.16.2. Will that work? Tell me if this works. 12.501.6.9. Will this work? Why not?
501.
501. It has to be between 0 and 255. Right? So this one's ugly. Never worked, right? How about this? Will that work?
Yeah.
Yes or no? Huh? Are we good? Yes or no?
Yes.
Not bad. So I can actually have 0.0.0.0 all the way up to 255.255.255.255. You feel me? That's what I'm trying to tell you. Does this make sense? This is just the basics. We're just teaching the basics right now. Okay, now, here's the deal. You have to be able to understand how to convert a number here to ones and zeros. You have to be able to convert this to ones and zeros. You have to be able to convert this to ones and zeros. You have to be able to convert this to ones and zeros. It matters. All you have to do is know how, what it means. I'm not saying you have to actually do it all the time, because you're probably going to use a calculator. Or you're going to go on the internet and say, what is the, if this is the number of ones and zeros, what is the actual dotted decimal number? And it'll spit it out. You say, oh, okay, you write it down and you put that number into your equation. That's how you're going to do it in the real world. But you need to understand the math behind it. This is probably going to be the most math that you're going to do in IT. This cyber, what we're doing right now. That's it. Hey, there's no calculus. There's no, unless you go into getting a PhD in cryptography, then you got no calculus. That's a whole new ballgame. Here, this is pretty much it. I'm just going to give you the foundation, okay? Just the basics. You with me? Okay. So now what I want to do, I'm going to give you a number, and we're going to convert this number into ones and zeros. That's what we're going to do. That's how it goes. And then I'm going to give you a bunch of ones and zeros, And then you gotta convert that into numbers. It's not hard. It really isn't. A lot of people like to make this difficult, but it's not. So, the first thing you need to understand is Mr. Darrell's chart. Came up with this chart, and it belongs to me, and every time you write it down or think about it, you owe me a penny. You just have to send me a check. So every time you write this chart down, it's called Mr. Darrell's chart. See, I came up with this chart, so it belonged to me. And it's copyrighted. Whenever you talk about it, see, right now you owe me money, because if you say Mr. Darrell's chart, you owe me some money. Okay, here's the chart. 1, 2, 4, 8, 16, 32, 64, 128. That's the chart. So the question is, how do I use the chart? Okay. Mr. Darrell said every time you see an X, you use my chart. Mr. Darrell's chart. Use it here, use it here, use it here, use it here. So let's start with this guy right here. Use my chart. 1, 2, 4, 8, 16, 32, 64, 128. It's just like this. You do that for that X. Then you do it for this one. You do it for this one. So let's do it for the next one. Let's see. I'll do it like this. You know what I mean. I'll just break it out like this. That way it'll make sense. So I do X dot X. Alright, dot X and dot and my last X. And I use Mr. Darrell's chart here. I use Mr. Darrell's chart here too. 1, 2, 4, 8, 16, 32, 64, 128. I just put some lines underneath just so I can just keep things copacetic. Same thing here, right? Do this one. Okay. 1, 2, 4, 8, 16, 32, 64, 128. Okay. And do the last one. Okay. 1, 2, 4, 8, 16, 32, 64, 128. Okay. All you gotta do is remember that. Are you with me? Okay. So now, this is how it works. If you're given a bunch of ones and zeros, for each one of these little areas, it's always in eights. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's good. Bits. This is a bit, 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 bit. Looks like 8 bits to me. Bit, that's a bit, 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 bit. Bit, bit, bit. A bit can be what? 1 or a 0. That's not bad. So think of these as placeholders. It's going to either be a 1 right here or a 0. 1 right here or a 0. 1 or a 0, 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 1 or a 0. Same thing here. 1 or 0, 1, 0, 1, 0, 1 or a 0. It's got to be either one or the other. It's either 1 or 0 for each place. So what you do is you get a bunch of 1s and 0s, you take them, you break them up into 8 pieces. Count. 8 pieces. Do you see the 8 pieces?
Yeah.
Here's the long number you'll get. Now you won't get this, but I'm teaching you how it works. You break it up into chunks. You chunk it into 8s. 8s, 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 8. Look, 8. Is that not 8?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Same thing up here. Then you go and bring the next 8 down. Put a dot to separate the 8s. 8, 8, 8, 8. How many 1s and 0s are those? Not 24.
32.
8 times 8 times 8 times 8. Yeah, 8 times 8, 8 times another 8, 8, 16. Y'all are pathetic. Y'all didn't do this.
I didn't
Y'all
even
awful.
pass, man.
8, 32. Hey,
Yeah, you did say that. You did say that.
8 times 4 is 32, man. Y'all see, y'all don't like Schoolhouse Rock. Y'all don't even know about no Schoolhouse Rock. Y'all need to look at Schoolhouse Rock. Figure 8 is another 8. Okay, whatever. So that means I can have in an IP address. And this is actually an IP address. There are 32 bits, 1 or 0. So if I give you a bunch of 1s and 0s, here it is, a bunch of 1s and 0s, you break them up into 8s. You break them up into 8s, and then what do you do? You put the 8s underneath Mr. Darrell's chart, which you owe me. Because you thought about Mr. Darrell's chart, you owe me some money. So grab this one right here, the first 8. Tell me what I got. Choose red. Let's use another color, red. Come on. What's this one right here? Grab the first 8.
192.
Oh, okay, so you already an accountant, so you ready to go home. 1, 1, and a bunch of zeros, right?
Yeah.
0, 0, 0, 0, 0, 0.
What's this next set?
1,
1,
0,
0,
1,
1,
0,
0,
1,
1.
0, 0, 0.
Okay. What's the next set?
0,
0.
4, 1,
How many ones?
4,
Oh man, I really messed this one up, didn't I? Then what?
0,
0,
1,
1? Oh man, that's a hard one. Okay, what about this one?
1,
1,
0,
0,
0,
0,
0,
0, 0,
1,
1,
0,
0.
0.
Oh, that's easy. Wherever you see a 1, you add. That's it. You don't get no better than this. But you gotta remember Mr. Darrell's chart. What's this one right here?
192.
How you know it's 192, man?
Because what the ones is, you add them up.
Add them up, add them up. 128 plus 64, do it in your head. This one is 192. You know, it's 0, so you don't add the zeros. You don't add, when you see a 0, you don't add that number. So this one is 192. Got it? Do this one. You gotta do some thinking, drinking. I'll help you out. 128, right? Plus 32 plus 8. What is that, man?
168.
168. I'm gonna go with what you just said. 168. Okay? Ooh, Lord. Let me do this one. 64. 32. 16. 8. 2 and 1. Yeah, somebody do that real quick.
123. Yeah, 123.
123. 123, right?
Yeah.
Oops. 123. 123. Oh, this was real easy.
That's 132.
That's 128 and plus 4. What's that?
132.
132. So that's the number. That's the IP address. So all I did is I do a conversion from binary to dotted decimal. See, I gave you this. I gave you a bunch of 1s and 0s. So look, I gave you this. You chunked them into 8s. You put them on the Mr. Darrell's chart, and you came up with a dotted decimal number, which is the IP address. A dotted decimal number is an IP address. The IP address is always broken down into 8 1s and 0s, 4 times, 32 bits. Each 8 is called an octet. Octet, 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 octet. So it sounds like an IP version 4 is made up of 4 octets. And each octet is 8 places. 1, 2, 3, 4, 5, 6, 7, 8. This is what you have to know.
bunch of ones and zeros. Can you convert?
Yeah.
And you know what I'm gonna do. That's how I roll, right? It's gonna be tough. I don't know how I'm gonna do this. So let's do it. You gonna let me do this? Yeah. Whew. How am I gonna do this? Did I give you the answer yet? No, I didn't. Well, let's figure it out. How do I blow this thing up? View? And then, oh, is it review? One of these, man. Oh, zoom. Zoom it up to 200. That's not bad. What do you think? You wanna blow it up a little bit more? 400? Okay, that's crazy. But, you can see it though, right? Okay, so what I would do is this, get your sheet of paper, and start out with the first one. You got, how many of these you got? A whole bunch of them. Okay, 4 of these. And I got the dots, so here's the first, on this one, this is a IP address. But what I'm asking you to do is to take these ones and zeros, put them underneath Mr. Darrell's chart, and tell me what the IP address is. Who wants to lead the class? I'll lead this up. All you gotta do is come up here, put your ones and zeros on here, add them up, and then you give me an address. You got it, brother? Okay, here, you wanna use red? Red and black. Make it happen. There you go, brother. All you got. You can erase the, erase those. Start with this one first too, right here. This shouldn't be too bad right here. I made this one easy. This one's hard. I did it intentionally. This one's not bad right here. You better knock this one out in a couple of minutes. Okay. All right? All right. There you go.
Yeah, that's right.
There you go, coming. Continue, man, unless somebody else wants to take it play. Y'all did see the numbers? Get them down right?
That the first one? Man, I thought you were finished by now. Yeah, knock this one out right quick. 192,
Wait, are you sure it's six?
153, 34, and 6, right?
Shouldn't it be five?
4. Oh, that's 5. 4 plus 1 is 6. I'm sorry. Hey, 4, what kind of math is that? 4 plus 1 is 5. You good on that one? 32 plus 2, 32, 34. 128, 16, 8 and 1, I guess so. And this is the easy one. It's always gonna be, 192 is always easy. Because it's first and second, that's 192. Who's next? Come on, go. Who's second? This one's easy, I'll help you out. 0, 0, 0. 0, 0, 0, 0. 1, 0. 1, 0. Period. Okay, next one. All zeros. 8 zeros. Good. Okay. Next one is, let's take it slow. 0, 1, 0, 1, 0, 0, 0, 1. Okay, next one. Last one. 1, 0, 0, 0, 0, 0, 1, 1. All right, knock it out. We're on this one now. Let's see how we doing this. This one's bad.
What do we do with the sheet here that you gave to us? Do we need to hand it in or
No.
keep it?
This is for you. Yeah, this is for y'all's purpose. What I'll do is, everybody sign in, right?
Yes, sir.
So what I do is, when you're on the borderline from an F to a D, I'm gonna go back and look at all these sign-in sheets and do what I can. Because you've been showing up. So, and if you're on a C and a B, I'm gonna try to help you. If you're on a B and an A, you might be on that borderline, like 88, 89, 87. I might be able to do something for you. That's
What's
how
the
these work.
definition of a binary system?
Hmm?
What's the definition of a binary system?
You
And
tell me what's the definition of a binary system, y'all. We've been talking about this all year semester. What's a binary? All right.
and,
That is the definition of a binary system.
and dotted decimal.
Dotted decimal, what is the definition of a dotted decimal?
Look up on the board.
Planet Earth, right? Yes or no? Well, it may not be in some countries with their number system. No, everybody uses 1 and 10 on planet Earth, right?
Yeah, that's
Yes. Well, let's say you in Papua Guinea, and you use bananas and coconut, man, but it's still, that's a tallow system. It's still 10. We use base 10 on planet Earth. What is the hexadecimal system? I'm asking you, what's the hexadecimal system?
Hexadecimal system.
Yes, what is it?
No idea.
Yes, you do. We just talked about it. Hexadecimal is based on what? 8 plus 8.
16.
16. Now you get it?
Yes, sir.
Binary is,
Ones and zeros.
dotted decimal is,
10.
10.
hexadecimal is.
16.
Okay. Now we good?
Yes.
Did you finish, man? 8 and 2, right? Yeah. That took a long time. Right? All zeros?
Uh-huh.
0.
Yes.
You had to kind of work with this one. Let's see, that was 64 plus. Yeah, it looks good. All right. Lord, man, this one's rough. Let's do it. I mean, we're doing it, we gotta learn, right? Let's do it. Come on. 1, 1. 0. 1, 1. 0, 0, 0. Yeah. Period. Ready? 0. 0, 0, 0, 1, 0, 1, 0. Okay, next. 1, 1, 0, 1, 1, 1, 1, 1. Okay, period.
0, 0, 1, 0, 0, 0, 0, 1. Check them out, man. 128, 54, that's 192. 192 plus 16. What's that? 192 plus 16 plus 8. 216. So that first one is 216. No, sir. 216. That's right. 216. Okay. What place are we? 8. 10. Yeah, that's 10, right? 8 and 2 is 10. Jesus. All right. 255 minus 32. 255 minus 32. See, if you add all of these up, it's going to be 255. So the only thing is missing is 20. So 255 minus 32, what is that? Oh. I passed my come to you. 223. That's it. That it. And this one's easy. Let's see. This is the.
It's 5.
Oh, sorry. Where are we here?
Yeah.
30, oh, 33. Yeah, you're right, bro. Come on, man. Let's knock this out. Last one. Let's do 1. Yeah, you want to erase that? Yeah, let's do that. Last one. Okay. So here we go. 1, 0. 1, 0. 1, 1. 0, 0. Period. 0, 0. 0, 1. 0, 0. 0, 0. Good job. All ones. 1, 2, 3, 4, 5, 6, 7, 8. Good man. Next one. 0, 0. 0, 0. 0, 1. 0, 1. Knock it out. Yeah, I knew you were gonna get that one. That was easy. Good man. 8. What is that? 8, 8, 1, 9. Oh, 5. I'm sorry. You're right.
That one's 172.
Oh, boy, this one's odd. No,
172.
172? All right. That's it. So let's do this. Take a 5-minute break, come back, and we got to do the reverse. Sorry, we got to do it. Either you do this now or you're going to do it in net fundamentals and then fail. So you got a choice.